Welcome back. So in this section, we will discuss about the meaning of positive work done and negative work done. Okay, so we will consider the situation which we have taken earlier as well, in which there is a football and which has been kicked off by a footballer. So we will discuss that situation only here. So here we have an initial stage of situation and it's a later stage or final stage of situation. In the initial stage, the velocity of the ball is zero and hence the kinetic energy of the ball is also zero. The kinetic energy has been shown symbolically with a box and we can see here the box is empty and hence kinetic energy is zero. And after applying a force F by the footballer, some energy is getting transferred to the football. Okay, and that energy got stored in the kinetic energy of the ball. Okay, which has been shown diagrammatically here. Means it has been shown symbolically only. Okay, so after applying a force, the velocity of the football has increased to v, and hence the kinetic energy of the ball has increased to half mv square. That can be seen symbolically as well. That here the box is empty and hence the kinetic energy is zero, whereas here the box is completely filled and hence there is some amount of kinetic energy which is getting transferred by the energy of the footballer. So if we compare the initial stage and the final stage, here we can see clearly that at initial stage the kinetic energy was zero. However, after application of force F, the kinetic energy of the ball has increased. So there must be a positive exchange of energy in the initial and the final stage. Energy of the ball has increased as compared to the initial situation. Initially, the energy was zero, and later on, after applying a force F, the kinetic energy of the ball has increased. Okay, so in this case, where in the final stage, the energy of any object has increased, in that case, we say that work done by the applied force is nothing but positive work done. Simply saying, if energy at a final stage has increased, then work done by that force is positive. Using the expression as well, we can conclude this. We have seen the work done by force is nothing but dot product of F vector and displacement vector. And here we can see that the applied force is F, which is in x direction, and the displacement d, which is also in the x direction. Okay, so the angle between F and d is 0, so we can write this here as FD cos phi. Phi is nothing but angle between F vector and D vector, and here the F vector and D vector are in the same direction and hence the phi will be 0, that is FD cos 0, that is equal to FD. So here also we can see that work done by the force F is positive, that is equal to F into D. So we can conclude here that if force and displacement are in the same direction, then only work done by that force will be positive. Okay, consider its contrary situation. Here we can see that, yeah, here we can see initial stage of a ball and a final stage of the ball. Here the situation has changed. Initially the ball is moving with a velocity of v, and hence its kinetic energy will be half mv square. At this stage, a force F is getting applied on this ball, and due to application of this force F, at a final stage, the velocity v of the ball has terminated to 0, and hence the kinetic energy has also come down to 0. So if we compare the initial stage of the football and the final stage of the football, we can see that some energy has been transferred out of the football. Okay, that has been diagrammatically shown here. At initial stage, there was some amount of energy, and that has been shown symbolically as a ball which is filled, as a box which is filled with energy. So this ball was filled of kinetic energy, and in a final stage the velocity is zero, kinetic energy is zero, and hence this box is empty now. So as compared to initial stage, in the final stage some amount of energy was drawn out of the football. So in this particular situation in which some amount of energy is getting out of the football of, or for that matter any object, we say that work done by that force is negative. Okay, just compare it with the initial situation in which in the where work done was positive, this box was initially empty and later on some amount of energy was transferred to it, and at a final stage some amount of energy is getting stored in this ball instead of losing it. So if something is getting stored in a body or an object, we call as positive work done. However, it's to its contrary, we can say that some amount of energy is getting out of the football or getting out of the object. So at a final stage some amount of energy was getting transmitted away from the ball, away from the object. And if energy is getting away from the object, then work done is negative. We can show this with the work done expression as well. We know that work done by force F is nothing but dot product of A vector and D vector, that is equal to Fd cos phi. And again, what is phi? So phi is nothing but the angle between F vector and D vector. Here we can see that F vector is pointing to the left, whereas the displacement D vector is pointing to the right. And hence there is 180 degree angle between F and D, cos 180 degree, which is nothing but minus Fd. And hence work done by the force F is nothing but minus Fd. So from here also we can conclude that whenever the force and the displacement vectors are acting in opposite direction, then some amount of energy will be withdrawn from the object, and in that case work done will be negative. So this is the meaning of negative work done. Negative work done simply means energy is getting withdrawn from an object. However, positive work done means some amount of energy is getting transmitted into the object. So something we are taking in, that is positive, and something which we are giving away out, then that is negative energy. Positive and negative simply means something is getting in and something is getting out. That's it. We will discuss further.